Hello students, welcome to this lecture on General Physics 1. In this lecture, we are going to discuss the main topic, vectors. This topic is quite broad, so we are going to divide into 4 lessons, and we're going to discuss first the scalar versus vector. In this lesson, we're going to differentiate scalar and vector quantity. And the second one is vector addition. We're going to perform addition of vectors using various methods. In this lesson also, you will learn how vector addition differs from the conventional process of adding quantities. In the third lesson, we're going to rewrite vectors into its component form. There are many ways to rewrite it, and this will help us especially on the succeeding topics in general physics that involves vectors. And the fourth lesson will be all about the applications of vector and vector additions in real life situation. So I hope throughout the duration of this lesson, you will learn something about vector and you can apply it on the general physics 1 subject. You will learn all of these lessons and eventually use them for the succeeding topics that you'll encounter in this subject. So let us now start with the first lesson. Now let us start with scalar versus vector. We're going to differentiate these two quantities. Maybe you are not new to this topic, to this lesson about scalar and vector. You might have encountered this already in your junior high school, but since it is part of your learning competencies, we're going to discuss this as part of our lecture at this time. So, before we delve on the difference between the two, let us first reacquaint ourselves with the physical quantities in physics. So we have two categories of physical quantities. By the way, physical quantities are any number that would represent a measurement. Now that is, it could be your height, it could be your mass, but these quantities are further categorized into two types. We have fundamental and derived quantities. So let's talk about first the fundamental quantities. These quantities are called fundamental or basic because of their nature of being the most basic in physics. No? That means that we cannot derive mass literally. I'm talking in a literal sense of measurement. We cannot literally measure our mass by measuring our height or our length in terms of height, and we cannot measure our mass by measuring time. That is very impossible. That is why we can only get the value of mass, length, time, current, temperature, amount of substance, luminous intensity by directly measuring them. So don't get me wrong, I know you're thinking about the manipulation of formulas, but that manipulation only happened on the derived quantities, because derived quantities are formulated from the fundamental quantities. Maybe you are thinking that, no sir, makaderive mig mass kung naami sa speed or velocity or sa acceleration, force over acceleration, ma-derive na mo ang mass. So that's it. All the derived quantities are actually quantities coming from the fundamental quantities. So before we deal with scalar and vector quantities, you need to learn first. You need to know what are the fundamental quantities and the derived quantities. You have to have the skill on differentiating these quantities first. You have to know what are the fundamental and what are the derived. For example, displacement. Displacement is just a quantity derived from the dimension of length. And so as with area, when we calculate area, we are multiplying dimensions of an object, which are actually all of these measurements are expressed in length, although we're using length, width, and height, that is for the volume, but length, actually length times width times height is good as length times length times length, because width and height is just a measurement of length. So volume now will become, the answer for a volume would result to a unit of L to the third power. So that means all of this area and volume is just a derived quantity from length. With speed, it is just a proportion of length and time. This distance over time. So all of these quantities are just formulated coming from the fundamental quantities. So in a literal sense, that is why they are called derived quantities, because they are formulated from the physical fundamental quantities. So although we know these two categories, these categories can still be further categorized into scalar and vector. So those quantities that I have mentioned, those fundamental and derived quantities, we can use them for dimensional analysis. This analysis is just a process to check the correctness of our unit when we measure something and even when we calculate quantities. So this analysis will start from our fundamental quantities. Here we have mass, length, and time with the dimension of m, l, and t. We are using mass, length, and time here because in General Physics 1, the topics in the first quarter to second quarter are all it is more on motion, forces, and these quantities are highly involved. Mao ni ang kasagaran nyo makita ng mga quantities. So ang gamit sa dimensional analysis is to check whether your answer is correct or not in terms of the units. For example, acceleration. We know the formula for acceleration is the change in velocity over the change in time. And we know that velocity is just displacement over time, and time is just time. So we know that distance is just a dimension of L from length and over time and then time. That will result to L over t squared. So in any calculation that you will encounter in physics that involves acceleration, you will know that your answer is correct if the units that you came up with would involve length over the square of time. So for example, upon your calculation, you arrive with an answer that like 30 meters per kilogram squared. By just looking at the figures and the unit, you will know that your answer is correct or not. Based on our dimensional analysis, the unit for acceleration should be length over time at the square of time. Here, when you arrive in this type of answer, you will know that your answer is wrong, or there must be something wrong with your calculation or your how you manipulate the formula. So basically, that is the purpose of dimensional analysis. So let us now define scalar quantity. Scalar quantity is any quantity in physics that only involves magnitude. That means these quantities are only concerned with the number value of their measurement and its corresponding units. Example for these quantities are speed. We have speed. It is a derived quantity and at the same time a scalar quantity. And we also have mass and time. We also have distance. All of these quantities are scalar quantity. It only involves magnitude, the number of its the number value of the measurement in their units. For example, for speed, we can have 35 meters per second. For mass, we can have 3 kilograms, and for time, we can have 30 seconds. Distance, we can have 5 meters. That's it. We are only concerned with the magnitude and the units. For the vector quantity, it is the complete opposite of scalar quantity. It is now involved both magnitude and direction. This is very common. Example is velocity, the opposite of speed. So we can have 35 meters per second due to north. Now we have here the magnitude, and we have here the direction. Another can have displacement, the counterpart of, the opposite of distance. We can have 5 meters due to east. This is also a vector quantity. We have here the magnitude and the direction. We can have also acceleration. Acceleration is just a derivative of velocity. The second derivative of position is acceleration. That means we can derive acceleration from velocity, and since velocity is a vector quantity, it is logical to say that acceleration is also a vector quantity. So we can have 5 meters per second squared, or square second. So these are the example of vector quantities. For mass, we cannot say that mass is a vector quantity because it's kind of awkward to say 3 kilograms to the north. Wag lagi paminawon. Dili bagay, no? Or 3 seconds to the east. That is why mass and time is considered as scalar quantity. If you go back to our table, if you notice, all of our fundamental quantities are scalar quantities, and some of our derived quantities are scalar, just like speed, and area and volume, those are scalar quantities, and the others like displacement, velocity, acceleration, and force, all of them are vector. Mostly in physics, most of the derived quantities are vector quantities, and all of the fundamental quantities are scalar quantities. So that is how we differentiate scalar and vector. So we can further differentiate, we can further understand scalar and vector quantity by examining the quantities itself. Now we can have speed and velocity. So we can learn more about scalar and vector quantities by asking this question: what makes speed a scalar quantity and velocity a vector quantity? So basically, the answer lies on their formula. Speed deals with distance covered by an object over a period of time, and velocity is more concerned on displacement and time. So for example, an object will travel from A to B with a distance of 10 meters, and it took the car, this object, to travel for 5 seconds. So automatically, your speed will become 10 meters over 5 seconds, and that is 2 meters per second. So that is your speed. For velocity, since we are dealing with displacement over time, in this case, displacement is just a change in position. So in this case, an object changed its position from A to B, and the distance or the displacement that it covers is also 10 meters. That is how it displays 10 meters. So eventually we will arrive with the same answer. So that is 2 meters per second. This will only happen if an object will travel along a straight line, and the answers would become different if the object will now travel from this point B to another direction, to another destination, in connection to this traveling process. So for example, if the object or the car, say for example the car will travel from A to B, then afterwards nibalik siya from B, nibalik siya padulong diri nga point, and that is point C. So let's just say nga straight ni siya nga line, straight line. That means nibalik na siya ani nga path dira. And for example, kani siya nga distance kay 4 meters. Nya ni siyang na cover nga distance from B to C for just 2 seconds. 2 seconds. So if we're going to calculate the speed of the car from A to B to C, obviously you have to add all the distances. So speed will become that is 10 plus 4. So you will have 14 meters over total time 5 plus 2, and that is 7 seconds. So you will have again 2 meters per second. But the answer for velocity will not be the same, because this time you will not consider displacement as the distance you cover from the starting point to the final point. In this case, as I have said before, kani nga path kaning B to C kay the same nga path sa A to B or B to A, but dire siya nga point ni stop. So if this is 4 meters, that means nga ang A to C is just 6 meters, and that is now the displacement of the car. So to calculate velocity, you will no longer use 14 meters. You will use 6 meters over 7 seconds. So obviously, the answer would be, 7 meters. And that is way more, that is way smaller compared to our speed. So you will now notice the difference between speed and velocity in one destination. So if an object will travel from A to B and then go back to point C, you will have different value for their speed and velocity. So because speed is more concerned with distance and velocity is for displacement. That is how speed differs from velocity. That is because of their formula, distance and displacement. And displacement in this case is also concerned with the direction. So for example, this is in this direction, the direction is east, and it's logical to say sa opposite na side dito ang west. So in this case, ang direction sa atong velocity, ang ihang resultant nga direction kay dili man padulong sa A to C. That means our velocity is due to east. Kaya dili man siya padulong. So that is how you differentiate scalar and vector quantity. So we just finished the first lesson on vectors. I hope you have learned a lot about vectors and scalar, their differences, and hopefully you can use them in the succeeding topics, especially on adding vectors. So that's it for lesson 1. Thank you.